Continue the session for today. Today would be the feedback session on your exam. Okay. So these were the questions what we have discussed. I mean, what you got in exam. So we'll see what were the questions. So now, if you have a question in this, you can ask now. Okay. So the first question here is there are 47 questions what I gave to you in exam. Of them, you got 15. So 15, it is a random question bank. So now, when I explain you about the question, you can ask me the doubt on that question. Okay. So the first question, what we had in the question bank is, so dash can be used to detect and mask repeats in the range. Okay, and the correct answer here is repeat masker. Okay, so anyone of you having doubt here? This one? No, because it's a straight question. There is no confusion in this. Okay. Are you able to see the question bank now? Whatever questions are there?
Yes, sir.
Okay. So now we'll go with the second question. So solid sequencing or ABI solid sequencing? What is it? Is it the first generation, second, third, fourth, or fifth generation sequencing technology? Srividya.
Second, sir.
A little bit louder.
Second, sir.
Second generation. Okay, that's the correct answer. Okay, the next question is biological state nanopore based sequencing and solid state nanopore sequencing approaches are whether they are first, second, third, fourth, or fifth.
Fourth. Fourth.
Elisha?
Fourth, sir.
Fourth generation sequencing technologies. Yes, nanopore based technologies are fourth generation, and they have two types: biological and solid state nanopore. Okay, and the next question is related to this. Biological nanopore sequencing approach is fourth generation sequencing technology. Okay, so next question here is cell-free tumor DNA can be sequenced by which generation technologies? First, second, third, fourth, or fifth? Which one? Sriran. Balaji?
Sir,
Balaji, which generation it is?
fifth, sir.
Fifth generation. Okay. So the difference between the four generations and the fifth generation is till four generations they're looking at sequencing the longer genomes, and fifth generation is looking to sequence the short length fragments but of high quality. Okay. Again, the same question. Cell-free tumor DNA can be sequenced by in fifth, which method is used? Is nothing but ultra sensitive nanopore sequencing approach that is used to sequence cell-free tumor DNA. The other approach also we have, it is high fidelity DNA sequencing. Okay. Now the next question is fragment and map assembly consists of. What is the answer? Atika.
So,
What is the answer there? Fragment and map assembly consists of what? The following steps. Which one is the correct there?
it's all of the above, sir. Overlap, layout, and consensus.
Yes. First step we have to make an overlap. Second we have to make a layout, and third we have to make a consensus. It's all the above. Okay. Next one. High throughput sequencing means Devika. Devika. Yes, Devika. Are you there in the class? Devika?
Sir, she is having some network issues, sir.
Okay. She will contact me. It's not a problem. Okay. Abhishek. 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 Kudurupak Abhishek. Even she has, I mean, even he has a network problem. Charan.
Sorry. Yes.
What is the answer there? High throughput sequencing means. Charan. Fast. We have to discuss 50 questions. Yes, tell me the answer. High throughput sequencing means. Charan.
Sir, it's
What is the answer?
QN.
High throughput sequencing. High throughput sequencing means. What is the answer, Charan? Okay, Padmini. Padmini.
Yes, sir.
What is the answer?
Sir, I didn't get you. I mean, there is some network issue. Can you repeat, sir?
High throughput sequencing means.
Sir?
High throughput sequencing. What is high throughput sequencing?
Sir, can you hear me?
Yeah, I'm able to hear you. Yes. Padmini.
Sir,
I'm able to see the
sir,
screen.
can you hear me?
I'm able to hear you.
Yes, sir. Yes, sir. I can hear you now.
Are you able to see the screen?
Yes, sir. Now I can see, sir.
Okay.
So, can you repeat the question?
High throughput sequencing means.
It is a next generation sequence. Where
Not
it
bad.
includes three.
No, it is not that. The answer here is A. Running thousands to billions of reactions at once with next generation sequencing technologies. That's the answer. Okay? Okay? Got it?
Yes, sir. Yes, sir. Yes, sir.
Okay. So the next question here is high fidelity nanopore sequencing and ultra-sensitive sequencing approaches are? Which? First, second, third, fourth, and fifth. Which one is among them? High fidelity nanopore sequencing and ultra-sensitive nanopore sequencing approaches. Gunadeepak. 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 Are you there?
Yes, sir.
Yeah. High fidelity and ultra sensitive sequencing approaches are first, second, third, fourth, and fifth. Which one?
Sir, it's A, sir.
First generation.
So you asked high throughput sequencing means, right?
No. High fidelity nanopore sequencing and ultra sensitive sequencing
Okay, sir,
approaches.
it's fifth, sir. Fifth.
Fifth generation sequencing technologies.
Yes.
Okay. The next question is also same. High fidelity nanopore sequencing is fifth generation technology. Okay. Now this one. How many generations of NGS technologies are known till now? Anjali Tiwari.
So 5.
5. Yes. That's the correct answer. Okay. The next question is Illumina or Solixa sequencing belongs to which generation? First, second, third, fourth, or fifth? Srinivas.
So second generation sequencing technology.
Yes. Illumina is second generation sequencing technology. Next one. Ion torrent sequencing is first, second, third, fourth, or fifth generation. Uday. Yes. Oh, your voice is breaking.
Second generation, sir.
Yes, correct. It's second
Second
generation.
generation. Second
sequencing.
generation, sir.
Okay. Okay.
Yes, sir.
Next one. Maximum Gilbert sequencing is first, second, third, fourth, or fifth. Gopal Rao.
Sorry, it
Gopal.
is first generation sequencing technique.
Maximum Gilbert is
First
generation sequencing.
technique.
Okay. Okay then. Gopal Rao. Same question to you again.
Sir,
Maximum Gilbert sequencing is also known as, what is that? Here options are dideoxynucleotide chain termination method, chemical degradation method, both or none.
sir, chemical degradation or chemical.
Okay, chemical degradation method is the correct answer. Okay.
Yes, sir.
Okay, the next question also to you. Maximum Gilbert sequencing is developed by whom? Sanger's, Maximum
Alan
Gilbert.
Maxim and Walter Gilbert. sir.
Okay, Alan Max and
Walter.
Walter Gilbert. Okay, correct. Okay, Elisha. Elisha.
Yes, sir. Yes, sir.
Non-coding reasons or the intergenic reasons in the genome are what? Tandem repeats, transposable elements, retrotransposons, DNA transposons, or all the above?
Sir, all the above, sir.
Yes, all the above. There are tandem repeats, there are transposable elements, there are retrotransposons, there are transposons. Okay, DNA transposons. And also any other thing which we missed here? Elisha, did we miss any other thing? It is not
No,
there in
sir.
option. Anyone in the class? Did we miss any other option which is not there in the syllabus? Now check this one and tell me later after the class. Okay. Okay. So the next question is Oxford Nanopore Technology ONT sequencing approach is first, second, third, fourth, or fifth generation technology? Ashrita. 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 Ashrita, are you there?
Yes, sir.
So what is the answer there?
Third generation, sir.
What is that?
Third generation.
Okay, third generation sequencing technology. So nanopore technology is the one which was implemented and it's the third generation sequencing technology. So ROCE 45645 for sequencing is first, second, third, or fourth, or fifth. Gopi Krishna. Gopi Krishna.
Second generation.
Yes. ROCE of 45 for sequencing is second generation sequencing technology. Okay. Okay, next one. Gopi Krishna, again to you. The question is again to you.
Yes, sir.
ROCE 45 for sequencing, ion tolerance sequencing, Illumina solid sequencing, and ABI solid sequencing are dash generation technologies. First, second, third, fourth, and fifth.
Second generation sequencing.
Okay. All these are second generation sequencing technologies. Okay. Sanger DNA sequencing is. What is that? Sri Vidya.
Sir.
What is that?
Sir, can you repeat the question?
Sanger DNA sequencing is first, second, third, fourth, or fifth generation.
First generation, sir.
First generation sequencing technology. Okay, right. Okay, the second question is also to you, Srividya.
Yes, sir.
Sanger sequencing is also known as chain termination method, chemical degradation method.
Chain termination
both or not?
methods.
Chain
Chain term. Yes, sir.
termination method. Okay. The next question is also for you again. Sanger sequencing method is developed by whom?
Sanger, sir.
Okay, what is his full name?
I don't remember, sir.
It's
I
Frederick
just
Sanger.
remembered. Okay, sir.
Okay, Frederick Sanger. Okay. So the next question is Balaji.
Sir,
Single molecule real-time sequencing approach is first, second, third, fourth, or fifth generation?
third, sir.
It's third. Okay, and the next question is also for you again. Single molecule real-time sequencing approach and nanopore
Sir.
and Oxford nanopore technology sequence approaches are first,
Same.
second, third, fourth, and fifth.
Same, sir. Third generation.
It is third generation. Okay. Okay. Okay, Harika.
Sir.
Solid state nanopore sequencing approach is first, second, third, fourth, or fifth?
Generation,
Solid
sir.
state.
Fifth generation sequencing technology, sir.
No, it is fourth. Okay. Solid state nanopore sequencing or biological state nanopore sequencing approaches are fourth generation sequencing technology. It is not fifth. Okay. Okay. Kirti.
Sir.
The part of the non-coding which is repeated from head to tail. What is that for us?
Tandem repeats, sir.
Okay, tandem repeats. Okay, correct answer. Then what is transposable element?
Jumping genes, sir.
Jumping genes. Okay. So I'll stop here till tandem repeats. We'll take a 5 minutes break. Okay, and then we'll come with the next questions. Okay, before going to break, do you have any doubts still here? Whatever questions I've showed you and I told you the answers. Do you have any doubts still here? All of you? All?
No, sir. No, sir.
No doubts? Balaji? Is your doubt
Not until-
clarified? Or
No,
you-
sir. It has to come in.
That's to come. Okay. There are 50 questions. I hope 25 questions are clear till now. So we'll see rest of the 25 after 5 minutes. We'll meet around 4:32, something like that. Is it clear? Okay. Okay, welcome back to the session. So we'll move on to discussion. So where we stop? Okay. So here we stop here. That is last one question. The part that part of the non-coding which is repeated from head to tail, tandem repeats. Okay. So we'll go on with the 5th generation sequencing technologies. Include Devika. Devika. Yes, Devika.
Yes, sir.
What is the 5th generation sequencing technologies include? What are the two?
So,
Is high fidelity nanopore sequencing or cycles ultrasensor nanopore sequencing. Okay, those are the two technologies which are used for sequencing short fragments of high accuracy, and they're known as 5th generation. Is it clear?
yes, sir.
Okay, then answer this question now. What is the 1st generation sequencing technologies? Sanger, maximum, both or none?
Both, sir.
Both Sanger and maximum Gilbert sequencing approaches are known as the 1st generation. Okay, Chandana.
Yes, sir.
So the following are the steps in genome sequencing strategy. Okay,
Sir.
these following are the steps in genome sequencing strategy. First one is generation of fragments. Second one is cloning of generated fragments. Third one is sequencing clones, or all the above.
All of the above, sir.
All of the
Above, sir.
So the first step is will sequence, generate fragments of genome. Okay. Then we clone these fragments in vectors. Then we sequence these clones. These are the steps. Okay. Now the 4th generation sequencing technologies are both biological nanopore sequencing approach and solid state nanopore sequencing approach. This is already we have covered. Okay, genome annotation involves 2 steps. This I gave an introduction and I stopped here in the previous class. Okay, what is that? Shivasagar.
Sir,
The genome annotation involves two steps. What are they?
sir, functional assignment.
Okay. Next,
I remember only one.
gene prediction. First step is gene prediction, and second step is functional assignment. Okay.
Okay.
These are the
Okay.
two steps. So answer here is C, both. Now, Balaji, the genome sequencing strategies include shotgun genome sequencing strategy, hierarchical genome sequencing strategy, both or none?
Sir, both, sir.
Both. So shotgun genome sequencing, genome sequencing strategies include shotgun and hierarchical. Okay. Okay. So the next question here is Atika.
Sir.
Important steps in hierarchical genome sequencing strategy are: one, generation of approximately 33,000 back poly library, chromosome mapping, both or none?
Both, sir.
Both. Okay. So what we do here in hierarchical genome sequencing is first we generate approximately 33,000 fragments, and then these fragments are mapped to a chromosomes. And then we'll continue with the shotgun genome method. Okay. So this is the actually important step in hierarchy. Okay. So next one is Balaji. What is the role of non-coding regions or intergenic regions in the genome?
Sir, it regulates gene expression.
Yes. The most important aspect here is regulation of gene expression. Okay. Regulation of gene expression. That is the answer. So the role of non-coding regions in the genome is regulation of gene expression. Okay. So already I told you the second generation sequencing includes all the above. It is Roshi 454 sequencing, ion tolerant sequencing, Illumina Solixa sequencing, and ABI solid sequencing. Okay. We have already discussed this. And third generation sequencing, this is also what we have discussed earlier in the previous bits. It's SRMT sequencing or ONT sequencing approach, single molecule real-time sequencing approach, or Oxford Nanopore technology ONT sequencing approach. Anjali.
Sir.
So what is the tool which is used for base calling? Fred, FRAP, consent, or none?
Fred.
Yes. Fred, FRAP, consent, or none? Not able to get you. Anjali.
So Fred.
Fred. Okay. That's the answer. Okay. So next one. Chandra.
Yes, sir.
The tool used for contig assembly. The tool used for contig
Sir.
assembly. It is
Option C, sir. Consent.
consent. Okay. Consent is the tool which is used for contig assembly and finishing the genome assembly. Okay. Devika.
Yes, sir.
What is the tool which is used for identifying vector contamination? Fred, FRAP, consent, or vector screen?
Vector screen, sir.
Vector screen. Okay. That's the right answer. Okay. Charan,
Yes, sir.
what is the tool used for read assembly in genome assembly?
Option D, sir. Vic screen.
Option?
Option D, sir. Vic screen.
Option B. What is that?
D, sir.
Yeah,
Vic
B, what
screen.
is Red screen. No. I asked you the tool used for read assembly and genome assembly is
Option B, sir. FRAP.
yes. Yeah.
FRAP, sir. Option B.
Okay. Okay then. Padmini.
Yes, sir.
So those elements in the genome which are able to change their location in the genome, what are they?
Transposable elements, sir.
Yes, transposable elements. That's the name itself. They're changing the location. They are known as transposable. Okay. Okay. Srinivas,
Sir,
these elements which resemble the non-functional segments of DNA that resemble functional genes. What are they?
pseudogenes, sir.
They are pseudo genes.
Genes.
So genes, they themselves change to non-functional and they are known as pseudogenes. Okay. Charan,
Yes, sir.
the elements which are transcribed into RNA first and then duplicated at another site into the genome. What is that element? Hmm?
Retrotransposomes.
Yes.
Retrotrans-
So they get first reverse
Option
transcribed
C.
and then they get duplicated in the DNA form here. So it is retrotransposons. And already I gave you ultra short DNA fragments are sequenced by. What is the answer? Because Srinivas,
Sir,
what is the answer there?
high fidelity nanopore sequencing.
High fidelity
Nanopore sequencing.
Okay. Uday Prakash,
Sir,
what coding vectors are used in genome sequencing strategies?
sir, it is all of the above, sir.
All of the
All of the above, sir.
okay. So back is a vector, last one is also vector, last one is also vector. So the answer here is all of the above. Okay, the last question here is whole genome sequencing of tumor or cancer is possible with. Here it is both 454 sequencing technology, Maximum Gilbert DNA sequencing technology, or Sanger DNA sequencing technology. Which one is the answer? Balaji.
Sir. Sir, it's 454.
Yeah. 454 sequencing is actually the technology that helps us to sequence the whole genome. Okay. So that is able to sequence the whole genome of a tumor. Now, Balaji, did you get your question clarified?
Yes, sir. In the first session itself, I got it clarified. I forgot.
So what was the question?
Sir, that just a second, sir. I noted it down. Sir, it's high throughput sequencing means. In the first option, NGS technologies was there, and in second option also it was there.
Yeah. But generating millions of fragments, millions to thousands of fragments using NGS technologies. That is high throughput sequencing.
Okay, sir.
Okay. So any doubts, other people? Any other
No,
doubts for
sir.
other people? So all your doubts got clarified now?
Sir.
Yeah,
Sir, I have a doubt.
yeah. There we go.
Sir, like high throughput sequencing,
Hmm?
like it should have two options, sir. Like it is also the next generation sequencing as well as it does all the million copies at once.
Yes. So what is your doubt there?
So I opted for both.
It cannot be both, because to generate millions or thousands of fragments at once, we use NGS technologies. So the option there is generating millions or thousands of fragments using NGS technologies. That is the option, correct option. Okay? Clear? Devika?
Like so for high throughput sequencing, it is also referred to as next generation
No,
technologies.
it is referred, but why it is used? What do you mean by high? High throughput. Generating millions of sequences in a time. That is high throughput meaning. Okay? But to generate that high throughput millions of sequences, we have to use some technology, and those technologies are nothing but these NGS technologies. Is it clear now, Devika?
Yes, sir.
Okay, any other doubts? Yes. No doubts? I advise you to go through the question paper, whatever you have attempted, whatever you have done wrong, go through them and check the options now. Okay?
Yes,
Is it clear? Each and every one, go to your question papers, refer them at this moment after the class is over, and check why you have done wrong or where you are wrong. Is it clear?
Yes,
To
sir.
all.
Okay, sir.
Okay, you do this, then only we can go to the next topic. Okay, so get clarified in that way. Now we'll move on to the next topic in the next class on Friday, that is genome annotation. Okay, so we'll continue with genome annotation and we'll summarize whatever you have learned in the first unit in the next class. Is it clear?
Yes, sir.
Okay,
Yes,
then.
sir.
Then we'll move on. We'll close this session. Okay. So bye. Thank you and have a nice day.
Thank you, sir.
Thank you, sir.
Thank you, sir.